Uh, Good morning, dear students. So, in this class, we will discuss feed-forward neural network. Uh, in last classes, we have discussed what is the basic perceptron, how to train it. Then we have just see a different variant, which is a logistic regression. And now we are just expanding from one node to multiple nodes, and let's see like how, and we have seen in last class as well, like there were different architectures. So in this class I will take a just to understand what is feed forward neural network, I will take a very simple example. And there are two different passes in it, like one is forward pass, then is backward pass. uh, we see them separately so that we can understand what is back propagation algorithm, right? So here is the example. So this is a neural network which is having two nodes, two nodes in a hidden layer and two nodes at the output layer, right? So there are edges which which is not visible here, right? So there are edges. Hmm. So at the inputs, we have just given 0.0005 and 0.10, and we are expecting at the output 0.01 and 0.99. So for this given input, my expectation is this, right? So, it, so this is just a simple example for when I am having only one hidden layer, right? So this is sometimes people call it as a input layer where we are feeding input, and this layer people call it like hidden layer, and this layer we can call it as an output layer, right? So the in just state of art, people use it. Sometimes people say it like three-layer network, or sometimes they call it two-layer network, right? It depends. The most of the people don't want to count input as a layer, and just they see the rest of the layers as a layer of a network, right? So we just follow the same terminology, and we say that this neural network is having two layers, and each layer is having two nodes, right? So just to discuss, like just to distinguish between two layers, I say that this is a hidden layer, and I say this layer as a output layer. There are two nodes in each layer, so I say that this is H1 node, first node of a hidden layer, and this is H2, second node of a hidden layer. And in output layer, I say this is a O1, which means that first node of output layer, and this node, second node O2, as a second node of output layer, right? And as from the arrow we can see that everybody is connected with everybody. So this is a very simple architecture of feed forward neural network, right? So just to calculate, just for calculations, we have put some random weights here. Weight 1 is equals to 0.15 and so on. And there are biases that is being shown, like for hidden layer H1 and H2, bias is same 0.35 for H1 and H2, and for output layer by B2 is also same, though they may be different, right? Just for an example and discussion, we have taken we have tried to simplify this example. So biases are also there. So I will try to show you like how we can calculate the prediction using this neural network, right? So this is a forward pass. What we do just to predict for a given input, what is the output? We first see this. We first come to this part which is being shaded, and here you see this that I1 is going to be multiplied with W1, right? You going to multiply this I1 with this W1. I am calculating the input here for H1 right now, what is the input for h1. So just for the notation purpose, if I have a node, I will say that the input to this node is uh, net, net. So this side of the input I will say net, and this side what will going after applying a activation function which may be sigmoid or 10h. We will discuss how many different variants are available for activation function. For simplicity, we will see that we will take like activation function only sigmoid here, right? So what we say that for the whatever input comes to the node, we say that it is net, and after applying a nonlinearity to this net, we say that the out this is out now, right? So for an example, if I calculate the net input of h1, right? So it will be nothing but you multiply I value with w1. Similarly, you multiply I2 with this w2, and they comes here. You just add them. You add the bias also, right? You just add the bias also. So here this is one path of input, this is other, and the third is like what is the bias. So we will just do it. So first I multiply I1 with W1, then I multiply W2 with I2. Finally, I will add a bias, right? I add a bias. Just for like simplification and mathematical purpose, we have introduced one more variable I0 here, which is always 1, right? So it is as good as it is not there. But you will see like how it will simplify in notation, right? So we have multiplied W1 with I1, W2 with I2, and B1, but then we need to add a bias. But before adding a bias, we just introduce a special symbol I0, which is always 1, right? So it means I am just adding B1 to it. Then I say that it is a net h1. It means it's a net input to the hidden layer hidden node h1, right? It's a net input here. Then I will calculate whatever the values are there, right? And I will finally get some number. Similarly, I calculate net input for h2 here, right? After when I get the net input for both the nodes here, what we will do, we just apply a sigmoid function, right? We apply a sigmoid function for this input here and for this input as well, right? So for both nodes, we will apply a sigmoid function and we get some value as the output of the node, right? So these are the values after applying a sigmoid function to this net input. So we say that these are the output of these nodes, right? Uh, just to show you like what is the advantage of introducing this I0 variable here is that now we can write these simple operations into a matrix form, right? So just to show you clearly, so these operations I can write it now in terms of a matrix form, right? So what we'll do, we form a matrix, right? And these are the biases we have just put in the first column. Then weights W1 and W2 in the first, W1 and W3 in second column, and W2 and W4 in third column, right? And I0, I1, I2, we take it as an input, right? So I0 is like this special symbol which is always 1, which is always 1. So now if you take a matrix multiplication, you will directly get a net input to both the layers. So you will get a vector. This vector is nothing, it will having some entries, and these entries are nothing but the input of node 1 and node 2, right? If you just feed this vector directly to a sigmoid function, right, you will get another vector because you are applying sigmoid element wise. So you get a vector which is nothing but a out vector, right? So most of the time, because you know that we are in the era of deep learning and we have CUDA, GPU, So we want to do parallel processing, and just to do things in parallel, we want to bring these things into a tensor form or matrix form. So that's why we are doing it. Just to put all the parameters and inputs into matrix and vectors, we have introduced this I0, right? This is all. Now we have calculated like what is the output of a hidden layer, right? What is the output of hidden layer, which is nothing but these two numbers. Then we see these output as a new input for the other layer, right? So the number which we got first is like, we see that it is here, and the other number is here, right? We are getting these numbers. Similarly, you multiply this output, right? So I say this out 1, right? I'll say out h1, out h2. So you multiply out h1 with this w5, you multiply out h2, right, with this w6. Similarly, like what we have done before, you add a bias, and this is your now net input for the output layer, first node, right? And similarly, you just calculate the net input for the second node of output layer. You just multiply this output h1 with w7, output of h2 with w8, add them, add the bias, whatever you get a number, you just apply the sigmoid, and you finally get the out of the second node of output layer. Similarly, you get the output of the first node of output layer, right? So likewise, we have did these operations, and we got the net input. We apply the sigmoid for the net input, right? We apply sigmoid and we get the final output, right? So we get the output. This is nothing but 0.75 and 0.77. You remember we were expecting this number, but my neural network, because I have some values to these parameter w1, w2 till w8, and for biases, I am getting this number 0.75 and 0.77, right? I am getting these two numbers. So there is a difference between these two numbers, and this is my error actually, right? So I have just finished my forward pass. In next video, I will show you like how to calculate my error, right?